going to begin our study of trigonometry. We're going to start to talk about angles in standard position. Now, angles in trigonometry work differently than angles in geometry, and I'll show you some examples as we go through this lesson. An angle in standard position has the vertex at the origin of a coordinate plane. And our coordinate plane still has a quadrant 1, a quadrant 2, a quadrant 3, and a quadrant 4. And our coordinate plane still has a positive x and a positive y in quadrant 1. In quadrant 2, a negative x, positive y. In quadrant 3, both coordinates are negative. And in quadrant 4, a positive x and a negative y. So those things haven't changed. An angle in standard position with the vertex at the origin also has what we call an initial side that is on the positive x-axis and a terminal side anywhere. We're going to even have angles that are bigger than 180 degrees. It's important that we indicate the angle that we are talking about. And this was called the terminal side. So let's talk about what we might already know in terms of angles. At the x-axis, we'd start with 0 degrees. And we all know that a 90-degree angle is a right angle. A straight line forms 180 degrees. And then if I add on another 90 degrees, we get to 270 degrees. And a full circle is 360 degrees. You've also studied some radians. So what we want to know is that 0 pi and 1 pi and 2 pi is a full circle. You should know that from geometry. Halfway in between 0 pi and 1 pi is 1/2 pi, or pi over 2. Pi over 2 is equivalent to 90 degrees. And then 3 pi over 2 is equivalent to 270 degrees. So those are our basic measurements at the axes of a circle. Once again, the initial side and terminal side are important. The initial side is always on the positive x-axis, and the terminal side is the ending side of an angle. We saw that on the previous slide. We're going to see in trigonometry, unlike geometry, that we have both positive angles and negative angles. Trigonometry is based on rotation. So if I were to draw an initial side and a terminal side, that would be a positive angle. And we often use theta to represent an angle measured. However, if I had the same initial side and terminal side, we could be talking about this negative angle. There's something that's very different from geometry. In trigonometry, we are working with rotational angles. A positive angle would go counterclockwise, and a negative angle would go clockwise. We're going to sketch some angles in standard position. Degrees are easier to work with because they're in a language we're more familiar with. What I would always suggest is maybe starting out by labeling your basic measurements. I know that's 0, I know that's 180, I know that this is 90. 159 is between 90 and 180. So I would draw my initial side, always in the same place. 159 is between 90 and 180, a little bit closer to 180. Okay, and I'm not done yet. I must indicate that this is the 159-degree angle. A negative 29-degree angle. If we're going backwards, we'd start at the x-axis 0 degrees, and going clockwise, this would be negative 90 degrees. Negative 29 is about a third of the way from 0 to negative 90. And again, I'm not done. I have to indicate with an arrow the direction of the rotation. We're also going to learn in trigonometry that we have angles that are bigger than 360 degrees, and that's just because they rotate around the origin more than once, kind of like the hands-on clock. All the way around is 360 degrees. So when I draw this angle, initial side, I'm going to go around the circle 360 degrees plus 30 more degrees. That is a 390-degree angle, which would not show as a 390-degree angle unless you had drawn in that pink arrow. Of course, your arrow doesn't have to be pink. Mine is. Radians are a little bit tougher. It's just a language we're not comfortable yet, but I promise we will be very soon. Again, I'm going to think about my basic 0 pi, 1 pi, 2 pi, pi over 2, and 3 pi over 2. Help me out. 11 pi over 6, where on earth would that be? Well, go ahead and divide 11 by 6. 11 divided by 6 is a little bit less than 2. It is 11 divided by 6, 1.83 repeating, or 1 5/6. So I'm going to think of this angle as 1 5/6 pi. We don't typically want to write it like this. This is just a part of my thought process, so that when I draw on my initial side, to find my terminal side, I would go to 1 pi and 5/6 pi, which is a little bit less than 2 pi, remember. So I'd stop right about there to draw my angle. Let's try another one. This takes a little practice, it's okay. We've got 0 pi, 1 pi. Each quadrant is a half of a pi. All the way around the circle is 2 pi. 10 divided by 3 would be 3 1/3 pi. So I'm thinking about 3 1/3 pi. That's just my thought process. I'd never give that as an answer for anything, but it just helps me know that from the initial side, I would go 1 pi, 2 pi, 3 pi, and 1/3 of a pi, which is less than a half of a pi. Each quadrant is a half of a pi. Finally, And then just to make it even trickier, we're going to do a negative angle. So that means I go backwards with my measurements. And you do not have to label your axes unless it's something that helps you. Initial side, that's the easy part. I can always do that. And I want to think of 15 divided by 4, 3 3/4 of a pie. 3/4 is bigger than a half. Keep that in mind. And because it's negative, I am going clockwise. 1 pi, 2 pi, 3 pi, and 3/4, which is more than a half. There's my angle in standard position. Other type of question we will start you off practicing is finding the measure of the angle that's indicated by the arrow. Some information's provided to you. Again, it's helpful to use some of our previous knowledge, 0 degrees, 90 degrees. Again, you don't have to label these unless you find it something that's beneficial. The angle we're asked to find right here, I just traced over it, is more than 180 degrees and less than 270. I can tell by the information given that it's 20 degrees less than 270. So that would be the math I do. 270 degrees, take away that little sliver of 20 degrees, and the angle I was looking for is 250 degrees. The next question, we have to make a notice that this is a negative angle. So I'm going to make a box for my answer, otherwise I'm going to forget to put a negative on it. I'm not going to do my math thinking in terms of negatives. I'm going to do my math just totaling up the size of that angle and then remembering that it goes in a negative direction. So what I'm going to think to myself is that each quadrant is 90 degrees. 90 degrees plus 90 degrees plus 90 degrees plus 40 degrees will give me the size of the angle. So that's the same as 270 degrees plus 40 degrees, or 310, except that it went in a negative direction. So I don't want to forget to label it with a negative. Question C also goes in a negative direction. But this time we are working with radians. Again, radians are a little tougher just because we're not quite as familiar with radians. I'm going to trace the angle, recalling that each half circle is 1 pi. So I'm going to count as I trace. 1 pi, 2 pi, 3 pi, 4 pi, plus pi over 3. So the size of this angle is 4 pi plus pi over 3. We need a common denominator. We're going to be experts with radians and fractions by the end of trigonometry. To get a common denominator, I'd multiply by 3 over 3. That would give me 12 pi over 3 plus pi over 3, which is 13 pi over 3, and it went in a negative direction. One more, and it'll be your turn to practice. and this does take some practice, but we are going to be working with angles all the way through trigonometry. So start with a very strong foundation right now. Okay, let's trace this one. It's a positive angle. 1 pi, whoops, I'm trying to trace. 1 pi, 2 pi. I don't know how much this extra is right here. So I can't say 2 pi plus something. Instead, I have to think, based on the given information, 1 pi, 2 pi, 3 pi is bigger than the angle I'm asked to find. So I will take that 3 pi and subtract that portion. You always have to base your math on what information is given. I need a common denominator, so I'm going to multiply by 12 over 12. That gives me 15 pi over 12 minus 5 pi over 12. No, I did some bad math there. I'm sorry. I have to multiply right here. I was looking at that like, what's going on? 36 pi over 12 minus 5 pi over 12 is 31 pi over 12, and it went in a positive direction.